Well, hello and welcome everybody. This is Protecting Your APIs Against attack and Hijack. This is Scott Morrison. I'm the CTO of Layer 7. And listen, I'm really glad you could join me today. This is going to be a really interesting 45 minutes or so. I think what we're going to do is basically cover the whole spectrum of what you've got to be concerned with if you want to be moving out in the platforming direction in your applications and beginning to create a good, secure, insulated API strategy. And so what I'll do is give you a bit of an overview of where the problems are and then suggest a bunch of solutions and mitigation strategies that hopefully you'll be able to use right away, and some you'll be able to use in the future as you move on and build out your APIs. So a couple of housekeeping things just to quickly get out of the way. Chat any questions you've got. Very often I find that by the end of this there's a whole bunch of different questions and I can't get to all of them. I'll try to cherry pick a couple of them. But what I do tend to do is actually contact you directly afterwards, because I think by signing up we got your email address here. And so if you do have any questions, I will try my best to actually get back to you if I don't do them publicly and start the dialogue there. And you can always contact me, of course, in other ways. My email address is scott@layer7.com, and I encourage people to use it and get out there and really start the dialogue. Hashtag for today is L7webinar, and of course you can follow us at Twitter at either Layer7 or my own Twitter is kscottmorrison. So with that out of the way, let's talk about what we're going to talk about. So really the big topic here is this new API threat and why it's a major concern for you and why we should be thinking about this is kind of a new potential attack vector and a new threat that we've really got to be concerned with. In a lot of ways though, APIs are a lot like the web, and so the problem with that is it tends to really lull us into almost a false sense of security, because we can think, well, you know what, we're pretty good at securing the web now. Yeah, we make mistakes and such, but if we just apply the same best practices, we're good, aren't we? Well, I would say no, and the real thesis of this whole thing is that fundamentally, really, the API movement, although it has its roots in web development, although it uses a lot of the same infrastructure and even the same naming conventions and that, is fundamentally a different thing. And so we have to kind of step outside and treat it as different. And in treating it as different, I think it kind of gives us a second chance to do the web right. Because I think, the problem with web development today, from a security perspective, is that it carries with it some baggage from the past, from limitations of our original infrastructure or our original programming model, which haven't necessarily evolved in step with the times and haven't necessarily evolved in step with really new infrastructure, new programming models, and new technologies in that. And so I think the thing about APIs right now is it's a chance to sort of stop and say, what do we do right, but what do we do wrong? And let's not do the wrong stuff anymore. Let's try to do everything right. And then finally, I'll talk about, what are the lessons of this whole talk. So in going through this, there's going to be three big areas that I'll touch on. The first is about parameterization, and a whole host of issues really revolve around this issue in how we're actually parameterizing our APIs and why that can lead to all sorts of different problems. Number two is about identity, and this is really, really important these days, particularly as we move out more and more into the mobile web. And as we begin to build applications, let's say for our iPhones or Android devices or even embedded devices in the whole Internet of Things and machine-to-machine communications, we've got to think hard about identity, because identity isn't as simple as it used to be. And then finally, cryptography is another whole I would say big bucket where we can put problems in and where we can sort of stop and analyze what we didn't do right with the web and really what I think we've got to do in the future that's a little better. So most of you, if you're on this talk already know what an API is, and so I'll gloss over this really, really quickly. Suffice to say, though, the API revolution is interesting, simply because it's really building on things we did do right. It's really recognizing that when we built the World Wide Web, we finally cracked the code of how to build a very highly scalable, highly distributed computer system, which is something we've been trying to do forever, like really since the first time we plugged two computers in together and called it a network. But we finally got it right. We finally built something that you can, create new applications and new websites and new servers. You can put them all up, and there's no central control or authority that really is going to take the whole thing down. And the beauty of the API movement really is it's recognizing that some things just worked in there. There's some techniques, best practices, infrastructure in that, which kind of work pretty well, when we're just doing web browsing to, from a, human to web browser to website, and we should be using those for something a little more sophisticated, like machine-to-machine communications and that. And fundamentally, that's really that acknowledgement of what the API movement is about. And really it comes down to, that fundamental idea of REST-based technology, which is really use those basic, kind of ideas in, that Roy Fielding expounded in his thesis of the basic architecture of the web can be used for so much more than just, web pages and transitions and that. And in fact, we can be using it for, all sorts of different data transfer and that. And the simplest example, of course, is just, using, something like the basic GET model. Really the, if you, think of it as the web being really a CRUD-based model with its, basic HTTP verbs. GET is the simplest one, that basic idempotent retrieve. And if we use the whole idea of the URL as really that identifier for a particular resource, and we get back a representation, in this case, a JSON-based representation of information about Scott, my name and address and things like that. We follow the model of the web, but at the same time do things beyond just, transfer of HTML pages and things like that. So simple ideas, but actually very profound. And really it represents a lot of I would say a sea change in how we're starting to tie computers together. I mean, I'm old enough to have done a lot of work, back in the, the bad old web services days where, we had what we thought was a similar vision of loose coupling based on, arguably web technologies and that. But the problem with what we were doing back then was that it really got overbuilt. What we did is we sort of said, you know what, HTTP is a great transport. Let's just make it a transport and nothing else. And then really let's use XML as a way of creating a data model and, which makes sense, but we'll sort of lay onto that a very RPC style communications. And it went from there and got more complex and more baroque. And when I look back on those times, a lot of great technology came out, and we're still using that technology to solve a lot of very good and important fundamental problems. But the issues with it were really around complexity and, I would say vendor motivations and politics and things like that. So the solutions that came out were overly complex and really, I think, in a lot of ways, sort of put this big and difficult barrier to entry in front of everybody. And really, the whole communications paradigm became sort of an end in itself. I mean, we had this idea that the protocol was everything, and the protocol was going to be the #1 focus. And you know what? It ain't about the protocol. It's about the app. It's about solving the problem and trying to get things done. And really the genius, I think, of the whole API revolution was sort of a lot of people stepping back and saying, you know what, we don't need to do all this. For most of what we need to do, we can just get by with, very, very, much more simplified approaches, which work well with every language, work well with every system, every architecture, and just fit within the mindset of what we've been doing for a lot of years on the web anyway. So really important technological sea change there, and really one from, complexity and barriers to entry to simplicity and virtually no barriers to entry. If you have Notepad, if you have a text editor, all of a sudden you can be coding up. You don't need to be buying infrastructure or anything like that. So important stuff. We saw this sort of flow towards simple, and in the end, in computing, the good solutions are simple, and simple tends to win. And so I think when we started to move into APIs, we got onto something. We got onto this thing where we were moving away from the complexity of vendor-driven standards and moving much more towards just get things done, put the focus back on the app, and really do it without a lot of overhead and friction and difficulty that has to be, sort of surmounted there. So when you look at that, you can sort of step back and say, wow, this sounds great. This sounds so easy. I mean, if it's that easy, you know, what do we have to worry about? We can just sort of defer back to the old web models and everything like that. Let's just use SSL, you know, for confidentiality and integrity. Let's just use, you know, basic authentication and the authorized header, and boom, we're done. Bob's your uncle. Let's go build some cool apps. And truth be told, you can do that. And truth be told, a lot of people do that, and a lot of people do that very, very successfully. But I think the real problem is, and the thing I want to leave you with here, is that in the end, if you stop and think about it, you know, API development is fundamentally different from web development. You know, we have different focus, and we're trying to solve different problems. And the danger here is that we start to get into this sort of pattern where we just try to borrow everything from the web, and without thinking about why certain things are the way they are on the web, we just sort of drag them in and adopt those practices in API design. And it turns out those practices may not be the best practices, and that's the real danger here. And I think really what I want to start talking about are the problem areas that are caused by, I think, not reflecting on the reasons the web is the way it is in some ways. And that's where the real threats are today. That's where I think we're really exposed, and the new potential attacks can come out by not acknowledging where problems were in the original web model. So let me go through a couple of these, and hopefully they'll start to resonate there. The first category, like the first kind of bucket that I want to talk about, is the whole thing about API parameterization. And when you stop and think about it, parameterization in the traditional web, and let's put aside Web 2 for a moment, just because I would characterize, you know, a lot of Web 2 and the use of XHR, like in other words, XML HTTP requests and things like that, is very much moving in towards APIs. So let's talk about, you know, the real simple Web 1, you know, which is all, you know, just sort of gets and form-based posts and things like that. That's a surprisingly limited vocabulary for interaction when you stop and think about it. You know, really, you're really boiling everything down quite literally to two basic fundamental HTTP verbs, you know, which are obviously get and post. There are more, and REST really steps back and says, hey, these other ones like, you know, delete and put are really important too, and even stuff like head can be important. But really, when you're thinking about the browser interaction, you know, it's just those two basic ones, and there's actually a kind of a good thing about that, because really it really kind of defines and circumscribes how you can interact with a back-end system. But then once we step back and start to add in, you know, the greater I think API vision, where we're beginning to really start to use the more esoteric components of the HTTP architecture. In other words, stuff like put and delete and things like that. All of a sudden, we've got to start to think about what that does to attack surface and how that can actually move attack surface into, you know, a much greater area potentially. And the minute attack surface starts to, you know, bleed into new areas and starts to get bigger, that's when you got a problem. Okay, that's when you've got to stop and think, well, maybe I have to look at this problem a little differently, and I can't just, you know, sort of treat it the way I did on the web, where I didn't have to worry too much simply because of the constraints of my communication with the back ends. The thing about good web apps fundamentally is that they really kind of constrain that communications. They constrain the kind of data that could you know, really interact with the back ends. And moreover, they really created indirection. So they created an abstraction between, you know, back end data sources and you know, the client themselves. And sometimes that abstraction wasn't particularly good. It may not have been particularly well designed. But the fact that there was sort of an HTML facade in there, and you know, there you know, may have been a framework, you know, implementing, I don't know, model view controller style patterns and things like that. It created this buffer layer, this abstraction between, you know, the lowest level of the application, where we're thinking about business objects and data objects and data in the database itself, and the actual view that the web client has access to. And the thing is that you could say that's sort of security through obscurity, but I'd prefer to think of it as more a logical constraint on your back-end systems, a logical constraint on your database and capabilities. And a well-designed web app takes that into account and narrows that view. So you're really forced into a very limited pattern of interaction simply through, your ability to get and post and the limited information that's sent back to you in the context of a web page. Now, think of that in contrast to APIs, because the thing about APIs is very often they're almost like a direct mapping of underlying functionality in an application itself. And the problem too is that very often they're auto-generated, and so they're almost like a window into the soul of the application. They're really, in a lot of ways, self-documenting about how the application is put together. So they're almost drilling deeper in. They don't have that buffer layer in a lot of cases. Now, of course, if you design your application well in terms of thinking about platforms, in terms of thinking about API, the first thing you're going to think about is how do I constrain that API so it doesn't necessarily reflect too much of my underlying application in that. But the truth is a lot of people don't do that. A lot of people auto-generate APIs off underlying implementations, and they give a tremendous amount of insight into the underlying application itself. And anytime you do that, you're really giving some kind of system cracker, somebody out there on the outside who may not be authorized to do stuff, on your back end, a lot of power. You're giving them a lot of insight into different ways that they can begin to probe that application and different things that they can potentially do. And really, when you think about it, what you're doing with APIs is moving your granularity boundary. So if you look at it like in the upper left there, the typical web app where you've got these levels of abstraction. You've got the model view controller abstraction for the web app itself, and then possibly other additional layers of abstraction which may consolidate different calls into other back-end systems or data sources or whatever. But the point is there is kind of a big granularity boundary in there between the app server and the web and the view that is given out to a client out there. So it limits, in a sense, that that view that person has. But in contrast, you're sort of moving that granularity boundary with APIs all the way out to the app itself. And of course, that gives just more attack surface. That gives more insight to the to a system cracker about what they could potentially do, but also more things that they can start to tweak. If that granularity boundary moves out, to, let's say, an application written on an iPhone or something like that. Maybe it's a phone gap-based application written in JavaScript where it's using XHR to make all these calls to, some kind of back-end system. A system cracker gets in there and starts to look at those calls and the nature of those calls and try to, it's just giving them more opportunities. And any time you get more opportunities, a wider attack surface, you're simply opening yourself up more. And so this is one of the fundamental issues with APIs, is that simply they open up those potential attacks more and more. And when you start to think about that, you really think that if you get that kind of control, like if you're getting that insight into the back-end system and you're getting more opportunities to inject stuff in, you can begin to, as a system cracker, begin to use the classic kinds of attacks that, really grew up on the web. But I think more and more we're going to see a tremendous explosion of in kind of modern application design, simply because they're very, very relevant there. And script insertion is a great example of this. The diagram here tries to sort of break it down into its sort of simplest components, which is the classic sort of script insertion that might go against a message board that hasn't properly sanitized its input. Where somebody might say, oh, I'm going to, a system cracker might do a post with an embedded, piece of JavaScript in it. And if that message board, of course, isn't scrubbing its data properly to intercept that and escape it out, it might go right into a post that then gets displayed on somebody else's browser, and then that, that gets interpreted as JavaScript, and boom, potentially anything interesting could be done on that receiver system. Now, of course, every message board around these days is, accommodates this because it's, it's an age-old attack. But the truth is that a lot of other apps don't do this properly. They don't sanitize the inputs. They don't necessarily think about the potential of a script being inserted that may come out and potentially run on another system. And it's not just browsers that they may end up on, because in the API world, of course, that could end up in, some other downstream application which, may have its own approach to interpreting and executing data. XML parsers are a great example of this, where, very often XML parsers, if they receive data and start to parse it will happily go through there and start to execute certain, call-outs and things like that. That might be, I don't know, transforms or, potentially even call in embedded code and things like that, which are, the kinds of interesting, sometimes esoteric attacks that, we at Layer 7 see happening in a lot of our customer environments, and we get brought in to solve those problems. More about that later. But suffice to say, script insertion is kind of an age-old attack that takes a lot of different forms. The other one is of course SQL injection, which is very, very related, and this again is about parameterization and manipulating parameters in ways that they shouldn't necessarily be manipulated. And I always like to think if you can possibly find an XKCD comic about something, about a particular topic, use that in a talk like this, simply because he'll say it better than I possibly ever could. And I love this comic just because it, every time I read it, it makes me laugh. Little Johnny Tables, but he nails it. He really sort of gets it. Like if you didn't know what SQL injection attacks were, you just read this and all of a sudden you realize, oh God, yeah, I totally get it. But the truth is that SQL injection attacks, if you look at the history of them, started back in the Power Builder days, like in the late 80s or whatever, and then migrated into the web. And now what we're seeing is these things are getting like this incredible second wind in the API world, simply because people are building APIs that to a certain extent, self-document what's going on underneath the hood, so that somebody who's actually trying to hack an application can just literally look at that API and deduce from what it looks like where the parameters are going to go, how they're going to be used, and can make a few logical leaps and conclusions in how to manipulate those parameters to sort of force a SQL injection attack, down deep underneath the hood of that application. It's a lot easier, it turns out, in the API world, in a lot of cases, than it was where you had those extra levels of obfuscation and abstraction in the web world, because the API is very often self-documenting. You can make some very, very good educated guesses by looking at the parameter naming, the ordering, what kind of information is going in and out, as to where there could be a potential, SQL injection attack, where those parameters could potentially map into a template, unchecked, and where you could actually do some interesting modifications. So this is one that's really had an amazing second coming there. So we're talking, we've been talking for a few minutes here about, parameterization and what to do about it, and or what happens. The next question is really what to do about it, and really what you should be thinking about, and it gets back to some basic, best practices that we've been talking about for years, but people always tend to forget about and overlook. And a lot of it just gets down to sanitizing input. You've got to, look at your parameters coming into an application and try to limit them as much as possible. Don't just say, well, everything's a string and we'll just take it as is and hope for the best. If possible, create typing on top of that. Create sets. Create limitations and ranges so that, basically the parameter is highly, highly, highly constrained, and then scanned, if possible, for the potential obvious attacks like SQL injection, script insertions, and things like that. Script insertions that come up again and again and again. Simply because then if that if somebody is fiddling around with the back end and they're not really thinking, about what's going on in the front end, you're still, you have that sort of initial, I think, secure stance. And so you're sort of protecting not just about what could be happening today, but what could be happening tomorrow as that application goes through its complete life cycle. And quite frankly, schema validation is a good way of dealing with this. Now, of course, in the XML world, there was great schema validation. It was horrendously complex, but it was actually very, very rigorous in that. And using things like XML Schema, you could do, all sorts of extremely rigorous and tight validation on parameters, and you can do typing on parameters and things like that. But the truth is that the world's moving away from that stuff. The world's moving much more towards using things like JSON and much simpler data representations. And that's fine, because it turns out that really for what most people needed to do, JSON is actually a much, much better, simpler, easier, more agile approach to doing things. And of course it automatically binds into JavaScript, which is a great thing. So luckily though, there's some JSON schema validation starting to come out. So you actually can apply this. Like you can write good, rigorous schemas for your APIs, and it is something that I would really highly advise. So schema validation ain't just for XML anymore. It's for all kinds of data, typings coming in. Now, in terms of intercepting, of course, other malicious content, whether it's a SQL injection attack, you're looking for selects and things like that, or deletes or drops, as in the case of the cartoon from a few slides ago. Regex scanning is great. Everybody knows how to do regexes, and you can build some pretty powerful ones, and they can be surprisingly fast. So, use those libraries, and they are there. The issue that comes up, and that we see, is you really do also, though, you can't do it just willy-nilly. You need to kind of tune things. Sometimes a parameter needs the word select in it. You can't just say, if you see a select, throw it to the curb. You've got to be a little more, I think, intelligent about what you're doing and kind of tune it to the problem at hand and that. So sometimes when people just apply generalized libraries, they get into all kinds of problems because they're throwing false positives all over the place. You've really got to think about that a little more. Virus scanning is something that, in the XML world and the SOAP world, we used to see this a lot more, and it's kind of gone away a little bit, but I think we're going to see more of this in the future as people begin to post in and use stuff like put as well for more interesting content. It's very often base60 forward content that is being sent into some kind of API, but underneath the hood, it's actually maybe a .exe file or something like that. Once it gets inflated back in a binary. You think about that, and think about the role of antivirus in there. Most antivirus, software vendors don't just do desktop. They've also got server-side versions of this stuff that you can, submit a blob to. So think about that if you're accepting big attachments of one kind or another. Like think about the role of finding a server-side antivirus system, that's constantly being updated with the latest and greatest, and taking that content and actually submitting it off to that. There's a protocol called ICAP, which is dead simple. It's a dead simple API that all the antivirus guys are using for exactly this purpose, so that you as a developer can, basically just take a blob of something, throw it out at the antivirus and say, what do you think? What is this? And get back a yay or nay. Highly advise people doing that and that. And of course, as much as possible, try to use libraries for this, but with a caveat that sometimes, yes, there are a lot of libraries out there, but sometimes they throw false positives, and you got to be able to tune them a little bit. Think also, though, about the possibility, and we'll talk about more closer to the end of this thing about decoupling security into gateway style solutions. Whitelisting, of course, is something that is also really worth doing, simply because if you can possibly do it, if you can possibly create that very, very limited subset of data coming into your application, do that, because then people can't run outside of it. Truth is, though, that's actually very difficult to do. Like most people, find that their apps evolve and the whitelists have to change, and whitelists are very difficult to maintain. At the very least, always blacklist the stuff that is bad, like script, JavaScript, declarations and things like that. So it really comes down to, the old filter input, escape output. Think about that all the time, and think about escaping the output. Like right now I'm talking about the stuff that's coming into you, but also think about what's being returned. That return path, that response to the API is actually really important too. Like in the same way that a good web app should think about the data that's sending back to people and maybe scrub some of that to make sure it's not sending back, potentially, bad data. Think about the same thing with an API. Like, the final step of sending back a request should be, maybe to scan through and making sure that you're not sending back accidentally some kind of injected, script or something like that. This is the thing that people overlook a lot, but it's certainly, worth doing. Identity is the second big area I want to talk about, and if you think about the web, we had it really good. The browser web model, identity model was actually pretty simple. Yes, there were a lot of different, variations on multi-factor authentication, and, some people just wanted to use username and password, but you could scale up on the web if you wanted to use you know, certificate-based authentication. You know, SSL, of course, has client-side cert authentication, you know, built into it. You can scale up to multi-factor. You know, people have managed to get Kerberos working on, you know, from web browsers and things like that. SAML is used for single sign-on all the time. So lots of different solutions. You know, surprisingly diverse. But really, when it got down to it, it was, you know, so much of it was about identifying a human, a person, and that. Whereas in the API world, we're moving much more towards these non-human entities. We're you know, getting the problem of applications and client-side applications and identifying those. And of course, the thing you see in the API world a lot is the use of API keys, which are really an identifier of a client-side application, or at least that's the intent. That's the intent. And of course, if you go to Wikipedia, it'll give you a bit of a, you know, vague description of what an API key is. But here's the problem. API keys, when you look at them, you know, you are one of these things that usually get, you know, just appended on to an API call. And in the case of a GET, here's the simplest version possible, you know, where it's just quite literally a query parameter. And so it's, you know, it's in there on the clear. And so obviously this thing, you know, if you're testing within a browser, you know, this thing is going to be visible up on the, you know, up in the address bar and everything. So it's, you know, you kind of see the anti-pattern already there where, you know, you never want to put any kind of important credential up there. But of course, if it's embedded within, let's say, I don't know, an iPhone app that's calling into some, you know, downstream API, you've still got a similar problem in that you've got this thing that's, you know, sort of quasi-authoritative and that, but the real problem is that there's an ambiguity in what it really means. Like, is that API key the person that's using it, or is it the app? And the truth is, the intent of the API key was always the app. It was always about a way of identifying a particular instance of an app and giving that app actually, you know, the ability to make a query against an API. So it's really, you know, it's kind of a terrible name in a lot of ways. I don't know why it came out this way, you know, API key, because it's not really about the API. It's really about the client-side app. It's really that identifier. But the truth is that what we see in our own experience and talking to a lot of customers that are building apps and using these things is that people aren't getting it. Like, they don't really understand where it should be used. And we, believe it or not, we have seen people using API keys like as an authoritative identifier of a person. Like a person, believe it or not. So it just, the whole thing it just smells. I got to tell you, it's not coming out very well. The truth is that as we move more into the API world and as we move more onto mobile devices and other kinds of applications and things like that, we're starting to see the need for a whole identity profile. So identity isn't just simple on the web like it was before, where it's Scott Morrison and he's signing on with his password and that's all you needed to know. Now all of a sudden we have this whole context that we have to sort of pull together, where it's the API key maybe, which identifies a particular app. We've got, you know, the user ID, maybe that's me, that's Scott. We've got device IDs in the case of our phones and devices like that. And then we've got a whole bunch of other attributes that we may have to consider, like the roles and the geographic location and the time of day and IP addresses and stuff like that. So in the API world, all of a sudden, it seems to be this forcing function where it's made us stop and think about identity a little more and realize that there's a lot more to identity than I think we dealt with on the web. And this has turned out to be a bit of a complex problem for a lot of people. And API keys in particular, I think, are problematic because they became early on this sort of ersatz, you know, identifier that people didn't really know where to use it properly. And I think it has a time and a place. An API key is a great thing for identifying like a particular application, not even a particular instance of an application. I mean all of one application. So in other words, if I build, you know, a cool iPhone app and I put it out onto iTunes, as a developer, I want to burn that API key into every instance of that app so that, you know, it can get authorized access as a particular app to some kind of back-end service. And that can be tracked and monetized, and, you know, SLAs can be applied to it and everything like that. So good reasons for it to exist, but just what's important is to recognize why it exists and where it should be used. And the problem area for all of this is that when you stop and think about it, it's almost like it's almost like an ad hoc kind of session tracking, because people actually use it for that quite literally. The API key becomes this sort of session where the first time you see it, you start to tie that to certain state. And that's a terrible thing. We should absolutely not be doing that kind of thing. We should not be trying to map it towards the same kind of session tracking that we did when we, authenticated on the web, and then, sort of use some kind of session identifier to be able to bind that to a human, to a person. An API key should never become part of that and should never really be used for that. And the reason, of course, is that, in the modern world, either, today or whenever, we've got tools like Firesheep and things like that, which I love that name. I mean, what an astounding image. But we've got tools like this that can just grab this stuff easily. And there's all sorts of attacks and things like that into keys like that that are very, very problematic. So bottom line is that, API keys have a reason for being, but they should never, number one, be authoritative, because they tend not to be treated as authoritative data. They tend not to be secured properly. And of course, they're burned into an application, so they're very, very easy for somebody to, reverse engineer that application and pull out the API key and use it for other things. By the way, that's an old trick that a lot of developers do with Twitter. Now that Twitter's getting harder and harder to get access keys for, people will reverse engineer other applications and use those keys to impersonate that application just to actually get access to APIs. In fact, I've come across a number of people talking about doing that. Simply as not because they're being necessarily malicious, but just because they want to solve problems. They want to get things done, and it's the expedient route rather than going through the usual channels and that. It's not the right thing to do, but it's what people are doing. And so we have to recognize, moreover, most importantly, that things like API keys are just not authoritative. They're there for basic tracking of applications, but not tracking of applications in such a way that, people may be necessarily charged to, or maybe you're making very, very important, kind of life and death decisions based on, simply because that thing isn't being properly, that is not a secure credential. That is not a credential that you can really, in the end, trust very much. And so you have to be careful about that, because this is an area where if identity is important, we need stronger approaches to identity. And I think Twitter took the lead here with moving to OAuth. I mean, they really, they recognize that I think API keys are one thing, but we also need a way of identifying people, bringing the human, bringing the interaction of a particular instance back into the whole equation. And then, their adoption of I think, OAuth over basic authentication, and that was, showed a lot of leadership in that and did exactly the right thing. So what I'm trying to get at with this is that what we're moving towards is this whole idea of a context, a lot of different sort of statements of identity, which need to be sort of pulled into this whole basic equation. Now, the big question that people come up with a lot, whenever you bring up OAuth is, oh God, what's the state of OAuth? It's, there's infighting, about it, and it's so complex and so difficult. And the truth is, yes, and yes. OAuth is tough. OAuth is difficult to use right now, and but I think it's getting easier. Like right now, we're still seeing, a fair amount of interop difficulty and things like that. But it's settling down. I think the fact that it's been ratified as a standard gives people, a place where they can draw a line in the sand. I'm very, very encouraged by things like OpenID Connect coming on very fast to solve sort of some of the other problems that we, that we're facing in terms of really giving a much more rounded identity strategy. I think we had a lot with SAML in the past, but SAML wasn't the right thing necessarily in the API world. So what we're doing now by, bringing out OAuth, by bringing out OpenID Connect, by, starting to evolve SCIM into things like user provisioning, is this really profound change where we're moving much more towards a whole identity context, but also this idea of a very agile approach to identity, where identity and management of identity and management of a particular account and ownership and authorization is moving away from central administration into a much more delegated administration, where the owners of the identity get to make the decisions about how that's shared and get to, basically authorize other apps, other people, other clients, other whatevers to get limited access to certain, aspects of that identity's information. And I think that's actually really profound. Like when I look at OAuth, we didn't need another security token. It wasn't another security token. What's really profound about OAuth is this shift, this really interesting shift towards, I think, user delegated and administered entitlements, and that, which mark my words, is going to be very, very important in the future. So let me leave you with this on this last section, is that the whole identity thing, in the end, what we've got to start to think about much more is that we've got a much richer identity context that we have to consider. It's not just about API keys. It's not just about the username and password. It's really about a whole bunch of different aspects. And really what we need to do and what we need to think about in our APIs is how we essentially deal with that. How we can make these statements of identity very authoritative, very strong, how we bind them together in such a way that they can't be easily hijacked, reused, and misused. And that's unfortunately a harder problem than you may think. Okay, area number 3 is around cryptography and PKI. And the funny thing is that PKI itself and certainly crypto is very mature on the web. But truth is, we don't really use it very much. Certainly we use a little SSL here and there, but most organizations, most enterprises, most large organizations sort of ducked the big PKI, bullet back in the 90s and just said, well, let's forget that one. Let's not really worry about it. But the truth is that as APIs get more and more advanced, and as we want to make or create more secure interactions with APIs, we're faced much more with having to think about some of these issues, not just about PKI, but also about how we're actually, beginning to, I would say secure transactions and secure the life cycle of transactions between an app and a server, using APIs. And the funny thing is, when I stop and look at it, it's, it really is like we, in the API world, we kind of forgot everything we knew, a bunch of years ago around PKI and strong authentication and key distribution and things like that. And quite frankly, we're doing a lot of just bad practices. There's a really good paper that went out, in the fall, so probably about 2 or 3 months ago, called something like the most dangerous software in the world. And of course, it's a very inflammatory title, specifically designed to actually, perk up people's ears. But what it was about was really an analysis of people's use of SSL, and in particular, use of SSL and APIs. And what they did is these researchers looked at the client-side implementations, the libraries in that encapsulate a lot of very popular APIs that are out there. Because of course, in the end, a lot of client-side developers don't like to get down and worry about low-level RESTful transactions. They want something abstracted away. They want to be working just within JavaScript, thinking about objects and stuff like that, not thinking about creating connections and talking through XHR to back-end systems and worrying about REST and everything like that. So most good big popular APIs out there have different encapsulations and things like that, and that's all well and good, except a lot of them don't do a very good job of setting up something simple like SSL. In the web, we were lulled into this sort of sense of confidence in that the browser did most of the SSL stuff. All we had to do was, change the line from HTTP to HTTPS, and boom, hey, Bob's your uncle, we're all done. It's great, we're secure. The bad guys aren't going to be able to intercept our transactions and stuff like that. And we kind of took that same model and we tried to move it into APIs. And the truth is that outside of the browser environment, we actually have to think a little more about what's going on when we're actually making a SSL-based connection. And we have to be a little more rigorous, I think, in validating, obviously the server-side certs and things like that are coming into us, making sure that, they go up to a trust anchor that we trust, thinking about our trust stores and what, signers, like what you know, CAs were actually trusting. I mean, this is a disaster on browsers still, you know, but it turns out that it's not much better in the API world, but it can be. Because all of a sudden, if we stop and think about this stuff, it gives us a chance to think about who we're trusting and what that web of trust really is, so we don't run into some of the problems that you know, we keep running into all the time. So the big issue, I think that fundamentally we're seeing, and I think what, you know, that paper really did a good job of pointing out, is that people aren't taking SSL and PKI and cryptography and integrity and everything like that very seriously. They're lulled into this feeling that, yeah, SSL solves all problems and it's really easy to do. And yes, it's a hell of a lot easier to do than the web services security model, where we went through and, you know, used XML digital encryption and signing and canonicalization and stuff like that to, you know, take SOAP messages and encrypt them. That was hard. That was really hard. It was really complex, and almost nobody got it right, it seems. The truth is that, yes, SSL is a lot easier than that, but it isn't perfectly easy, and you still have to think, you know, pretty hard about it. You have to think about trust. You have to think about the anchors. You have to think about the validity of certs and stuff like that. You also have to think about things like cipher suites and you know, avoiding downgrades and stuff like that, and limiting that list of cipher suites that you may actually be accepting. Again, the problem with the browser world is that it wasn't very limited. You know, you know, people didn't tend to go through and put many restrictions on it. APIs, though, are an opportunity. APIs fundamentally are there, you know, and are giving us a chance to stop and think about this again. And I would argue to kind of reevaluate this. So when I look at the problems around PKI and the problems around cryptography and things like that, I think a lot of them are really fundamentally about, you know, just avoiding like the stuff that we knew before. You know, I would argue that we really got to think hard about using PKI again and using it right when we set up our servers, but also think about the life cycle and the client side as well. This isn't like a one half of the problem sort of problem. In other words, you can't sort of isolate yourself and say, well, we're just going to worry about it on the server side and, you know, let those client guys work it all out. It's obvious. It's obvious. As much as possible, when we're designing our APIs, we should be designing not just for a good, secure server-side API, but in particular, designing around making it easier for the client-side developers to consume that API in a way that's secure. And that's actually harder than it sounds. It's not as simple as just telling them to turn on SSL. You've got to basically really give them the guidance in what else they should be doing and how things should be set up on, you know, at their end. You know, and a lot of that gets into things like checking, you know, CRLs and all the just muddy stuff that we know how to do, but we almost never do it and that. And so, you know, look to things like, you know, there's registries of certificates. You know, Google's got some good advice in its safe browsing API and things like that. So you know, look to some of the guidance right here. So where does it all leave us now? Like, you know, I've talked about three big areas. I've talked about the problems of parameterization, and I've said, oh, you know, we should be doing a better job of validating our parameters and you know, filtering input, escaping output, and everything like that. You know, we've certainly talked about API and PKI and all the issues there, and we spent a bunch of time thinking about identity in that. In the end, you know, I think there's a couple of different approaches we can take to really apply this. And number one, I really advise people to use SSL all the time, okay? I think, you know, despite what I've said about problems, you know, SSL is a lot harder to implement than it sounds. I think it really solves a tremendous number of issues. A lot of the problems in hijacking session tokens and hijacking API keys and things like that really come about simply because people tend to leave API interactions open, unencrypted, unprotected. And that's really, I would characterize that as a bad practice from the web. And think about where that came from. Like, think about your average website. You know, it's basically, you know, something you browse, And then all of a sudden you get to kind of the money shot. You get to something that, maybe a credit card number has to be entered, or, you have to put in some kind of personally identifiable information. And then what happens? Boom, SSL gets turned on, everything's fine. And the minute you're out of that, the minute your transaction's over, boom, SSL's off, and you browse. Now, think about where that came from. I mean, that came from back, in the late 90s or whatever, when SSL was really expensive, and we were having trouble scaling our systems and things like that anyway, and, people were spending money on SSL accelerator cards and stuff like that, and so SSL was a valuable commodity. But today, SSL is just a commodity. Like our, modern, CPUs really are so efficient. They can handle the crypto load with almost negligible overhead. And Google has really, shown us this. I mean, Google opened up all of their interfaces to say, yeah, sure, you can use Google and with SSL because, in our tests we found it just wasn't that big a deal after all. Yeah, it's not 100% free. You're going to take a bigger server load for it. But you know what? We're actually good at dealing with server load these days. We're good at scaling, and we're good at making those estimates. So I really adopt this sort of I think, stance that all API traffic should use SSL. Turn it on. Why wouldn't you? It's virtually free, and it deals with a lot of issues in token hijack and things like that. It deals with man in the middle as long as the client is dealing with the connection properly, and that's a very, very important piece in the whole thing. I really advise using OpenID Connect and OAuth and stuff like that. These are great technologies, and a lot of very, very smart people put a lot of time into them. Definitely use them because they, they're still evolving in some ways, but they're ready for prime time. And people are using these things for mission-critical, highly scalable solutions now. We see it every day. A lot of our customers are using it like that. And then also, for the love of God, use real frameworks. When OAuth first came out, everybody wrote their own OAuth implementation, and it was awful because a lot of people got it wrong. Because, as I mentioned before, OAuth is complex. It isn't for the faint of heart. Please go out there, find stuff that does it for you, because there are a lot of very, very good libraries out there. And of course, there are also pieces of technology that deal with all of this. Here at Layer 7, of course, we have something that we call a Layer 7 API proxy, which is really, a gateway-based solution that sits in front of API servers and gives security professionals the ability to really configure security policies for all of the APIs and do it very consistently. And think about that. If you're a developer working on the server side, that's tremendously liberating. If you can say, you know what, I don't have to worry about all this filtering, this filter input, escape output. I don't have to worry about the, dealing with all these potential identity claims and crap like that. I don't have to worry about interfacing with the PKI system and checking CRLs and things like that. If you can divorce yourself with that and say, you know what, that's somebody else's responsibility who's doing it for the whole organization and our entire API strategy, and they're doing it the right way and they're an expert in that area, I tell you, that is liberating, because then you as a developer can just get on to building great apps. That's really fundamentally what the API proxy is about. It's about that liberation. It's about, putting the tools in the hands of the experts to be able to build an effective, secure API, policy engine that sits in front of the APIs and just does all this stuff. It scans for threats. It looks for SQL injection attacks. It looks for script attacks. It does very, very tight constraints on all of the different parameters coming in and out of the application. And it separates that out from the API and separates that out from the application itself. So you're separating complexity out of your app. So it's a really, it's the right kind of focus. And the other part of the solution really is something we call the API portal, which is really about helping out the client-side developers. And trust me, they need the help, because if you just throw out an API and say, hey, we built it, they will come. Some of them might, but some of them might come and they might screw it up. You really need a way of empowering those client-side developers. You need a way for giving them the keys that they need so they can get access to, your APIs. Give them the documentation so they can learn how to use these things safely and securely. And then managing them, managing the applications that they build, through the life cycle of those apps. So if, let's say, a developer goes rogue or something like that, you can, kick them and their bad apps off, and they can't use your APIs anymore. And similarly, if you want to start to monetize your APIs effectively, that's a part of the whole solution and a part of the whole equation. So managing the client side, managing that new constituency of developers, I think is it's a movement towards what I think of as the new governance. This is an important part of the whole platform equation. It's not just about the server side anymore. It's about, the integrated whole. And you really need the tools to govern those interactions and govern all the parties available, like all the parties involved in that whole thing. So listen, that's it. I'd like to thank everybody for joining me. It's been, it's been a great chance to talk to all of you. A couple of things. There's a Tech Talk coming up January 29th. Although basically bursting in Amazon Cloud Auto Scale. We've here at Layer 7, we've got a lot of experience with that, because our gateway solutions are out there in Amazon, they're in the marketplace. We even run a hosted SaaS offering out there in Amazon. So this is going to be about war stories and things like that. So by all means, sign on, because the guys who are going to be doing that Tech Talk are the guys that have, been through the battles, and, they've got all the scars to show that, they've earned their stripes. So enough battle metaphors there, but trust me, that's going to be a really, really good one. Yeah, we've got a special Valentine's Day webinar as well. So, bring your sweetie to this one, February 7th. Be My API, how to implement an API strategy everyone will love. And yeah, that's one not to be missed. If you have any other questions, by all means, chat them out. Email me, scott@layer7.com. I will try as much as possible to reach back out to you and answer any questions, because we've run a bit short of time. So thank you, everybody. Hope you can come to some of our other events, and hope the rest of your day goes really well. Take care. Goodbye.